You too. It's fine. Thank you. Any questions? No concerns? Okay. All right, so I had a few things to mention. Okay, so the test is on Thursday. I will get into, in a second, we'll go over the antiarrhythmics, the very brief section of antiarrhythmics and what I expect from you. As far as the classification is concerned, I understand I got some feedback that I wasn't in line with pharmacology, and turns out Dr. Selvage missed a class to a snow day, and I didn't know that. So I'm sorry about the confusion with the, I presented all the stuff on time, but he's doing that high stakes quiz on Monday for the thrombosis coag section. Mm-hmm. So I'm sorry for that. That was a mistake on my part for not checking with Dan. So I guess the first thing I have on here is talking about the Dean's Forum. I got feedback from that about MedChem, which was, well, some of it was surprising, I have to admit. I got a summary sheet from the Dean's office, which was like a bulleted list of a few things. And I guess, the main thing is disorganized, slides incorrect or doesn't understand information himself, structures of drug molecules inaccurate. So I do appreciate that I make mistakes in my slides. Generally these mistakes are because I've kind of been rewriting a lot of these slides and making the structures bigger and darker. So when I'm retyping in the drug names, I get some mistakes. So I'll try and be better about that. There are, of course, some mistakes on the slides I had today, which I'm going to correct, so that makes me look bad again. I'm sorry about that. But there was one comment, he's not clear on what is testable and what is not. He is unclear. I think I could not be more clear about that. So that's something I kind of have to refute. I'm really going over and above what I usually do in class by giving you the study guide and all those questions. That's usually something that's actually I keep to myself. So I really I don't plan on changing my mode of organizing the class in that respect, because I all I got was kind of appreciation for that. So and there are some other things like small things, but then there was another document that came out during my yearly review, which was a 2-page typed document, which essentially summarized every single comment. And it's upon reading this, I wasn't, none of this makes me angry or anything, because I'm used to being evaluated pretty harshly by my peers, meaning the other professors in the department. When they sit on a class, I can expect to get a lot of feedback, and some of it's really hard to hear. But my only note about this document, the other one, the complete one, is that the language is a little harsh. For example, trying to trick us, violates confidentiality, belittling and condescending, responds to questions in a demeaning way, scoffs at questions, makes me feel uncomfortable, wasted class time. Professor becomes annoyed and snippy. So I guess I'm a friendly professor, and I'm very forthright with my feelings, and I'm a little bit jokier than some other professors. But I take your feelings very seriously, and I'm really not trying to put anybody on the spot. So if I'm engaging you in class, and maybe we're getting off track a little bit, I'm not trying to take this down a jokey path where I'm trying to be condescending in any way. So I don't really, like I said, it's not really anger, it's more like sadness that I feel. I'm disappointed that I didn't hear this earlier. So I guess in the future, make sure the professor knows first, because this came from the dean's office through my boss. So it's on record, and it sets kind of a tone for how you feel about me, even though it's maybe not everybody's opinion. So we're halfway through the semester now, and it would be a little bit easier if I heard kind of this kind of feedback maybe last part of the class, maybe a few weeks into the class, and then I could adjust along the way. So in the future, make sure your comments are constructive. It's hard to do that. I know when you're emotional, maybe that day in class I was not really impressive to you, but think of the bigger picture. And again, I appreciate the constructive comments because that's something I can work with and I can document and I can prove to my boss and my boss's boss, the dean, that I'm actually trying to improve. So that's my thoughts on that. I would ask for comments right now. I don't want to put anybody on the spot though. So if you have further thoughts on that, get back to me. And if there's serious issues with the class, please let me know. I'm really not. I'm trying to be. I was kind of shocked because I'm trying to be as open as possible. Not a lot of people have come and met with me and set hours to meet. Besides people who want to review the exam, so I do have the time to meet. And if there's something that's really you really feel burned about, then I need to hear it, and then I can act on it. So I guess that's my thoughts about the Dean's Forum. All right. But it is acknowledged. I appreciate that you guys tell the dean what you want. I think that she was a little overwhelmed by all the comments, but it's definitely something that I'll work on and try to improve on the comments. So, all right. Thanks. So let's go through the slides. I did have a minor study guide correction, which you probably noted if you went through the study guide. Let's get back to my study guide. You can see I actually changed this already, and it was this particular section right here where this set of questions was repeated in this section, and I have just I believe it was this section, right? Did I say carbonic anhydrase? Yeah. So in the carbonic anhydrase, I had the same two questions. I'd done a cut and paste error, and I hadn't actually modified the questions for carbonic anhydrase. This is what they should be. This is what I posted as soon as I found it on the website. So it's just a minor. A couple of my questions were off. So I hope that didn't cause too much confusion. You probably noticed it already if you delved into this. And while we're here, I do want to point out that there is a section. The exam has been written, and as far as the functional groups, I've given you kind of a narrow range of possibilities for questions. They are all going to be in the same modality as those three questions we talked about. So, just to be clear, in the chapter 2 questions, there are a whole bunch of questions at the end of the chapter, and in fact, I gave you a quiz, which was actually counted as a team-based learning, that quiz that was all the structures and didn't go so well as far as ExamSoft. But it's not going to be those kind of questions. It's going to be relating to a drug molecule and those three types of actual drug questions, so you can apply that knowledge to a real example. Okay. So that's how I'm going to frame those questions. And everything else should be somewhat clear according to the study guide what to expect. I will try and stick to the learning objectives. I do hopefully will stick to all of them. Like, the only, I guess you're dying to know, and you'll probably try and learn more about the test, but the only real difference with this test is it is a little longer. So it will be the same format. It will be multiple choice. I have not put on an extra credit question yet. I'll leave that. I'm still mulling that over. But the only real significant difference is that it's going to be a longer exam. Last exam was a bit short in my estimation, so I'm just kind of lengthening it. But I'm not going to go over the top and slam you. But I'm going to ramp it up a little bit in terms of length. Okay. Any other thoughts about the test besides what's on the test?
Is there going to be a chance to go over any questions we have from the study guide?
Yeah.
Would that be now or after?
Why don't I get through these slides really quickly? Antiarrhythmics, there's not a lot of content here, so let me do that, and then let's go right to the study guide. Let's see, today's class is the 3rd. Okay, so let's talk about the corrections that have been noted here. As far as the classification is concerned, this is recall the classification and recognize the chemical details specified for each class in this section. This is a cardiac action potential diagram that you'll become very familiar with. It's broken up into phases, all of which represent a different influx or efflux of ions that correspond to a Purkinje fiber, which is one of the so that's how you record the action potential. So you will spend a lot of time in pharmacology looking at this and identifying the sections, the phases of repolarization versus depolarization. And in fact, once you go into therapeutics, you're going to be looking at non-normal EKGs a lot. So you'll be giving an action potential, and it'll have a weird shape, and you have to delineate what's going on. And then after that, you're going to figure out what kind of antiarrhythmic to be using. So it's actually very interesting, and it's but the only real classification I am looking for is a fairly basic understanding here that phase 1, these are sodium channel blockers, so we have some. Phase 2 are beta blockers. Phase 3 are potassium blockers, and phase 4 are calcium channel blockers. And these affect all different parts of that action potential. So one of the typos, let's see here. For class 1, well,
No, we decided it was okay.
no, that was okay.
Yep,
It was
it's
okay
okay.
in this.
Yes,
There is no
it's okay.
corrections on this.
No correction on that
Okay.
one.
Sorry, I had a discussion before class. But this is, and on the right-hand side, I've put some representative drugs that we briefly touch on here. Okay? So really, it's just a classification of 1, 2, 3, and 4. I'm talking about. You don't have to delineate the 1A, 1A, 1B, and 1C difference, because that is a pharmacology question. The class 1A, the representative drugs are the quinidines. They are metabolized in 2 ways. So the first type of metabolism is loss of a methyl. So this methyl group right here. And it's called, instead of quinidine, it's called O-demthyl quinidine, which is, or quinine, excuse me. And O-demthyl is just a shorthand way of saying no more methyl on the oxygen. It's also called desmethyl, you might have heard, but O-demthyl is an acceptable alternative. The other type of metabolism is this hydroxylated vinyl group. So this vinyl, that is a terminal double bond, is hydroxylated during metabolism. And then finally I point out that there is a contaminant during preparation of the drug, which is just quinidine with a reduced double bond here. Reduced carbon-carbon double bond, not redunced. That's a contaminant from preparation that's actually very extremely toxic. So there's a historical context to that. When they first started making this drug, the last stage, during the last chemical step, a very small amount of that reduced form of the drug was created, and it was a while before they figured out what the source of the toxicity was, but that was it. So that bottom right, just to be clear, is not a metabolite. It's a byproduct of the chemical manufacture of the drug. Okay. Class 1A also includes the drug procaine, which I commented on. So I hope you all recognize that that has an ester in it. And I keep driving the point home that esters are not only chemically unstable, but they're also metabolically unstable because of non-specific esterases in the body. And this is a classic example of a bioisosteric replacement. I assume Dr. Mizuno touched on those. We are simply replacing the ester functional group with an amide. The amide is much more chemically and metabolically stable. And this gave a drug that was more orally active and more resistant to hydrolysis. Procainamide. The Class B drugs, Class 1B drugs, they have distinctly different cardiac effects. I think it's kind of obvious they're a different class. And they kind of get into specifics as to what, again, we're talking a particular type of arrhythmia, a ventricular arrhythmia in this case. But I would just like to look at kind of the evolution of this. We have lidocaine, which was modified subtly to give more orally bioavailable forms, tocainamide and mexiletine. So you can see they're pretty structurally similar, just slight modifications of each. So they are all grouped together. They all are used, still used. It's just that the tocainamide and mexiletine are the more orally bioavailable forms. And then one of the drugs in the Class 1B class, which is still used, is phenytoin. Phenytoin is actually used as an anti-seizure medication, but it has cardiovascular effects as well. Does anybody know what a hydantoin ring, like historically, what that's used for, or has anybody seen that before? Or comment on it? A hydantoin ring is actually a derivative of an amino acid. So, if we were to cut this molecule right here, down the middle of that 5-membered ring, and what we're left with, if I just draw the arrow ring part of the drug here, so we have 2 phenyl rings, and then all of a sudden you'll see that we actually have a amino acid here. All right, if I make that cut and hydrolyze this bond, so I'll just say hydrolyze here. This is actually an amino acid, right? Just this little pore here, and it's a di-substituted amino acid. Oops, I didn't have my double bonds in there. Right? So this is an amino acid with an R group that's 2 phenyl rings. And I want to point that out because the hydantoin ring, so a hydantoin is just an H, and then 2 hydrogens here. This is hydantoin. So in the old days, when scientists were studying amino acids, they had no means of looking at the drug, like nuclear magnetic resonance spectroscopy, or mass spectrometry. So they would take an amino acid and they would react it under certain conditions and form a hydantoin ring. And what that did was dramatically increase the boiling point or the melting point of the drug and allowed for compounds that were really easy to crystallize. So it made the drug really a lot less soluble. And then you could look up the melting point of that hydantoin derivative. So some of you might have even done this in chemistry class where you had a amino acid and you made a hydantoin derivative of it in order to get a melting point. Or at least I did, but that was years ago. So this hydantoin ring makes a lot of kind of historical chemistry context. But the ultimate result is that that cyclic 5-member ring is extremely insoluble. All right. So there's all these issues. So with phenyltoin, it's very slow to absorb, and it's a very poorly soluble drug. So it's difficult to formulate. But on the upside, it's not metabolized that quickly. So it's actually has a very long half-life. It can control the plasma levels pretty easily. Okay. Class 1C. These, I don't have any specific comments on these other than they are affecting the class 1, they're both in the same classification. They are, the only difference with propafenone is that it has a short half-life. And it's one of those drugs, I looked it up, you have to have multiple daily doses. Lecanemide has many drug-drug interactions because it's highly metabolized by P450 as well. So not much to comment on those. I just wanted to point those out because those are both used and Dr. Selvage will mention them. So I think importantly here, important facts, drug-drug interactions here, very short. Class 2 are the beta blockers. This is a typo. This is inhibitors of repolarization. You can't even see my comment there. So. Repolarization. And I think I've talked quite a bit about beta blockers enough. Sotalol is an interesting beta blocker. It has a very familiar looking right side, but we have a sulfonamide on the left-hand side. And this is mirrored in the class 3 potassium channel blockers, which are essentially sotalol derivatives. You can see they have the left-hand side of those beta blockers with the sulfonamide, but the right-hand side has been modified so significantly that they no longer have adrenergic activity. So these essentially are adrenergics that have been modified so they don't have adrenergic activity, but they're still having that effect of blocking potassium channels, which is a side effect of the beta blockers themselves. So they've been modified to actually be used for their side effect, and their actual standard use has been deactivated. This comment is not necessary to know, this amiodarone. Dr. Selvage might delineate the mechanism of action in this because it actually is a very unique drug and I used to go into it, but it's not really used that much, so I don't think it's as relevant. It's altering the lipid it's like a lipid membrane altering drug. So it has a very interesting mechanism of action, but it's so toxic it's not very used, so I did not comment on it. So we can not worry about this information here, okay? And then finally, the class 4 are the DHPs, and we've already gone through the DHPs, so I'm not going to talk much more about those. We've exhaustively covered those. So that's all the information, just those key points. This I will not test you on, but this is also something to keep in mind. Calcium channel receptors, like the ones I just mentioned, and this, I might have had this on your other slides, but the 1,4-DHPs, verapamil, and your diltiazem, all have allosterically interactions. So when you are co-dosing them, there's allosteric effects to keep in mind. So this is something definitely in pharmacology and therapeutics you'll need to know. So I just wanted to point that out, that I've only discussed the DHPs. because verapamil and diltiazem ostensibly were covered last semester. So sometimes they can affect one another. Okay? That's all for that. Then.
Just make sure really quick for the class 1B, we're changing the 3 to the 2. Because originally it was like, I just want to double check.
That one's being changed. No, I
No,
thought,
we decided to leave it at 3.
Oh, we're did.
no, yeah,
Yeah.
that original table is
Because,
fine.
yeah, that's fine.
So,
Okay,
thank you.
so Devin asked, and maybe we could get started. Is there something that I could go over on the study guide? Was that a good course of action here? Did you have a specific question, Devin, or?
I couldn't find for the potassium sparing aldosterone antagonists and carbonic antagonist inhibitors, the two questions, how the lactin rings are attached to the co-structure. Oh, just kidding.
Wait, did you say just kidding, or somebody else?
She did.
You're kidding?
Okay, never mind.
Never mind.
Yeah.
Oh, okay.
Missed
Getting all fired up to talk to you then. Is there any other comments that I can go through on this? Yes, Aaron. I'm sorry, I didn't hear the first part of the question.
But for the last exam, you kind of posted all the PLQs you had done.
That is another question. Well, I did not do that. I will do that. That's totally fine with me. Yeah, that's fine. The other thing is the marked up slides. Are there specific ones that are not on the website that you guys would prefer having? Because I have posted some of my marked up slides. Should I just get everything up there? Yeah, I'll put up the marked up slides. I've seen, in some of the cases I put them up right away, but in some cases I haven't, because I haven't got through all the slides in one day and I didn't post at the end of the day, but I should. But I'll do that. I don't even have to ask. I'll do that, Aaron. And I will absolutely put the pre-lecture quizzes up. So let me write a note to do that. And I can do that right away. Anything related to the study guide? Oh, yes.
Hypertension, part 1. Can you go over the first question for recall the function structures of metabolism of autonomic thyroid?
Yes. So these questions here. Well, how do they work using osmotic gradients? These drugs are not metabolized. So they are essentially creating a concentration of that drug in your urine, or rather that is going through the process of excretion before it becomes urine. It's in your kidney. And because there's a high concentration of this drug passing through your kidneys, passing through the nephron, it's drawing water with it through an osmotic potential. So, metabolically stable materials that you could dose that are going to go through your nephron and take water with them. Just simply because it's a solution, very high concentration solution that's drawing water, wants to draw water into it. So it's taking water from your through absorption when it's passing through the nephron. What structural class do they have, or are they similar to? Well, first, are they hydrophilic or lipophilic? They are hydrophilic. They're very water soluble in general. Urea is not, as in terms of pure solubility, not super soluble, but they all are similar to sugars. Mannitol is one of them. Isosorbide is just a sugar derivative. They have hydroxyl groups in them. They're small molecules. They're all very water soluble. If they were lipid soluble, then traveling after you ingest them, then they would probably be absorbed into the lipid membranes of your gut. They'd be more effectively absorbed like a drug. But the fact that they are polar and not rapidly metabolized means they're going to get into the excretion process really quickly. That is, get to your kidney and travel through there. So yeah, structural similarities. The ones that I pointed out are all related to sugars. I did put urea on there, which is one of the simplest ones. That's not a sugar, obviously. And then they are not metabolized, to answer the last question. Is that pretty okay? Lay it on me. What else? Anything really? Suggestions? Comments? Is there a particular section anyone? Everybody's so quiet. I know you have a lot of things to study for this week. Well, here we are again. It's the class before the exam, and we have a little extra time. You're welcome to do what you want. I will hang out here for a little while. You want to approach me as you're leaving? Yes. If you guys want to study elsewhere, just you can quietly leave. I'm gonna, but I'll address some questions as. Yeah. What's up?
What is the overall change of heparin at physiological pH?
Charge, or yeah, the change. Heparin is a polysaccharide, and it's highly sulfated. So a sulfonic acid is charged. It's an acidic functional group, so it is charged at physiologic pH. What kind of charge, Devin, would a acidic molecule have at physiologic pH? Do you know? Huh? What charge would? Sorry, what charge would a sulfonic acid have at physiologic pH? Negative, correct. Yeah, because that is this very acidic proton. It's going to fall off very quickly at a pH of around 7. So the overall charge, Devin, is negative. It's a very anionic species. It has tons of sulfates and some carboxylates. Heparin. And heparin derivatives. Sure. The novel ring system. Let me look at that question. In the ARB section, you said?
Yeah.
Just the one on in between.
So is it one of these?
Bottom one.
What novel ring system is present in all current ARBs? Is this acidic or basic? It's a great question. This is the tetrazole ring that I pointed out. So we're on ARBs, this last line here at the very bottom. What novel ring system is present in all current ARBs? Is this acidic or basic? What is it an
It's a tetrazole.
isosteric replacement for? The key ring that I'm talking about is the tetrazole ring. What was added to S8308 in order to make losartan was we transformed the carboxylic acid into an alcohol, and then we took that ring system and enhanced it, made it a double phenyl ring system with a tetrazole on it. That had the overall effect of increasing lipophilicity of the drug. The tetrazole ring is an isosteric replacement for a carboxylic acid. So interestingly enough, that 5-membered ring, if you have a drug that has a carboxylic acid in it, oftentimes you'll run into trouble because that's such an extremely acidic functional group that it markedly affects the absorption of the drug. So in trying to eliminate that, you don't want to add too much more molecular weight. And you want to find a replacement that binds in the same fashion, so it has a hydrogen bond donor. So that tetrazole, let me go to the slides, because I wanted to talk about this. Shoot. Get my back to my is that which?
Hypertension. Hypertension part 2.
Was that hypertension 2?
Yeah. Yep. That's
Let me just go to these slides here.
I couldn't find them. I think I typed it, but just answered that. So.
Just the carboxylic acid.
Mhm.
Here we go. Sorry. Okay. So I delineated adding that phenyl ring and the tetrazole, converting this to an alcohol, overall increasing the lipophilicity, and then I noted that all three of these drugs have this tetrazole ring system. So let me just show you what they probably saw here. What they probably had, just looking at the bottom part of this molecule, is they had a lead structure that had the two phenyl rings, but then had a carboxylic acid. Right? So this is carboxylic acid, double bond, and this is the bottom part of the molecule. Okay, oops, again, getting my aromatic ring designation. Okay, so let's imagine one of these drugs here. The only difference is on the bottom, that phenyl ring has the two phenyl rings attached to that carboxylic acid. And certainly, and probably during the development here, they identified a hydrogen bonding interaction. So we have a hydrogen bond acceptor, and this is a hydrogen bond donor. And we'll say somewhere in the active site, they identified an interaction that was important, right? So they defined that they found a drug that had a carboxylic acid. It's binding to something in the active site through a hydrogen bond interaction, and that carboxylic acid is necessary for the activity. Then they took that drug, they put it into an animal, and holy smokes, it's not absorbed at all. No oral bioavailability because it's too polar, too acidic. For whatever reason, the physical properties are too out of whack. Very common thing to do is to replace that carboxylic acid with a tetrazole ring, which does increase the number of nitrogens. So as far as Lipinski's rule, it's a little bit not ideal, but it's not nearly as acidic and can still engage in a hydrogen bonding interaction. So we would have the same drug, we replace this with a tetrazole. So if I can draw all these nitrogens so small here. And then we have this NH at the end, which I've pointed out here. See this hydrogen? And this hydrogen is a hydrogen bond donor as well. So the geometry and the hydrogen bond donor characteristics of the tetrazole are very, very similar to a carboxylic acid, but it's not nearly as acidic or as polar. So it's a much more lipophilic system. So it can still engage in that bonding interaction.
Where did the carboxylic acid come from?
Where-
Is that in our slides?
No,
Oh, okay.
no, this is a speculative
Okay.
what they saw. I can almost guarantee this is what they saw. If there's a tetrazole in this molecule, I bet if we look back in the literature, they found a lead drug structure that was similar on the top, but the bottom part had a carboxylic acid. And it's very common for medicinal chemists, if they're thinking about carboxylic acid replacement, the very first thing they'll think of is installing a tetrazole ring in that position. So,
So it's not nearly as acidic, but it's still considered acidic, or is it kind of on that?
yes, it is acidic, but it's not a pK of like 4 like carboxylic
So it's a lot
acid.
less. It's like
Yes. So it does have an acidic proton, that proton will come off under certain conditions if the environment is distinctly different enough in terms of pH. But it's not like as far away from pH 7 as the carboxylic acid, so it won't be as ionized at physiologic pH. And that kind of adds into why we put the tetrazole in. We want it to be a little bit more lipophilic, a little bit less polar, but still retain that hydrogen bonding interaction. It's a very good question. I'm glad you asked that.
I just have one more.
Sure.
Carbonic,
Keep going.
Carbonic anhydrase inhibitors.
Yeah.
Talking about a lactone ring and then you can't run that.
He corrected that.
That was the correction I made.
Oh, so that's gone?
Yep.
Okay.
Um,
different question.
Another different question.
Yeah, so that's the
Yep.
same, as if you look at just above that, it's the same, I did a cut and paste there, and I hadn't changed it when I posted it.
Yeah, it's-
That one?
It's posted, yeah,
Okay.
the correction is posted.
What was the question?
In the study guide on the carbonic anhydrase inhibitors part, I cut and paste the questions from the previous one and put them in before I typed them in, so I got the same font. And in the new version, I don't know, do you guys have a copy of your study guide here? So, yeah, so those are the wrong questions. You put in, those two red questions are the same ones that were below here. I did it, that was the error. The ones on the website, yes. Does everybody got that?
Yeah.
That's the only study guide problem I found. I would welcome your observations if you found some other typos. Yeah. Anything else? Anything bugging anybody? Happy to go through it. Yeah, Aaron.
At the very end of hypertension, part 2,
What section, Aaron?
hypertension, part 2, this drug is multiline.
Mulcitamine. Very last slide. Yes.
So, question being, it says it generates nitric oxide with oxygen and no enzymes or cofactors, but it says it's metabolized by liver esterases. So, is that saying, should the
Yeah, I actually, yes, because it does require an enzyme to get to lincitamine, right? So, and this is spontaneous. So I guess it would be more appropriate to instead of mulcitamine either to say SYN1A. Because once that active metabolite is formed, then it can actually form nitric oxide, but it only needs oxygen in that case. So liver. Liver esterases take it to lincitamine. It spontaneously ring opens. And then upon reaction with just oxygen, nitric oxide is formed. I was careful when I wrote the questions to account for this, Aaron, so there won't be any trickery on the exam. I specifically thought about this when I was writing this question out.
And
So-
then it says liver esterases. Is that technically a specific type of esterase? Because we had a good question that said like involves non-specific esterases. So we didn't know how specific the term liver esterase is.
Yeah, it is a specific subtype. but I don't have that information. The only, because you can delineate what those are in the liver, non-specific esterases are more in the bloodstream. In the liver, they're actually categorized, but I don't have that. I don't have that here. So it is a liver metabolism that's not occurring in the bloodstream. So I would say liver esterase. Yeah, and when I refer to non-specific esterases, I think usually I'm referring to the ones that just in the bloodstream. I think when I've commented on that in the past, I don't recall saying non-specific liver esterase. That wouldn't make sense. Liver esterases are all delineated.
Yeah. I just need a microwave to heat up my lunch. Is there anything else?